What's up, Algebra 2 students? This is lesson 35. And the first thing we're talking about is the measure of the interior angles of a polynomial. Well, we know triangles all add up to 180. And so if we kind of use that same idea for all the rest of them, like a quadrilateral, if we draw this, notice we have two triangles. So all of them in this one up here on the top would be 180. All of them in the bottom of this one would be 180. Then if you add them together, this would be 360. Same idea here for this one. If I draw some diagonals here, this is going to be 180, 180, and 180. So it's going to be 540. This next one here, 1, 2, 3, so I'm making 4 here, so it's going to be 180 times 4, or 720. You can keep going with this, but you get the basic idea here is we're going to take 180 and multiply it with something to do with the number of sides. So notice this one up here has 1, 2, 3 sides. This one has 4 sides. And this one we took 180 and multiplied by 1. This one we took 180 multiplied by 2, 180 multiplied by 3, 180 multiplied by 4. So notice it's kind of just 2 less than the number of sides. This one has 5 sides, this one has 6 sides. So it's just going to be the number of sides, which is n, minus 2. So it would be the sum of the interior angles of an n-sided polygon. Alright, now what about this, some of the exterior angles? We're just going to look at a few simple ones here, some that are regular. Well, we know that this is a straight line, so that means this angle and this angle must add up to 180. So this interior one is 60 degrees, that means exterior one is going to be 120, which means this would be 120 and this one would also be 120. So if we add those up, that would come out to be 360 degrees. So if you add up all those. Same idea here. This is 180. The inside one's 90. That means the outside one must be 90. So 90, 90, 90, and 90. So if you add up those 4 90s, again that would be 360 degrees. So the sum of the exterior angles of a polygon is always 360 degrees. Then we kind of take that principle here, and here's a strange looking polygon here where we have lots of different exterior angles. And we just go through and add them all up. So that's exactly what I've done here, is I've just added those all up for you. This one, plus 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 this one. Okay? And then, of course, we just found out that this is going to equal to 180. I don't know why I just said that. 360. So this is going to equal 360. That means 2x is going to equal, if I subtract 290 from both sides, 70. Dividing by 2, x is going to equal to 35 degrees, or 35. Well, and then that means this one here is going to be 35 plus 55. So that means this angle is going to be 90, and again, these two would add up to 180, so that means y is going to equal to 90 as well. Okay. Here's another theorem. It's also in your book, but it says that if you have an inscribed quadrilateral, which means if you picked 4 points on a circle and drew lines between them, that'd be a quadrilateral. It'd be 4 sides. That's inscribed, meaning it's inside with the vertices on the triangle, on the circle. Then the sum of these those opposite interior angles, this one and this one, these two will add up to 180. And some of these two will add up to 180. So we kind of just use that principle for something like this here. So notice I have 75 plus y. Well, those two are opposite, so that means this must equal 180, which would give me that y is equal to 105. And then that would tell us that x is equal to 100. Alright, now this next one we need to remember that if we have an inscribed angle and an intercepted arc, this arc is equal to twice the inscribed angle. So inscribed angle is 80, so if we double that, we will end up with this inscribed angle, which is z plus 50. So we will have 160 is equal to z plus 50, subtract 50 from both sides, z is equal to 110. Alright, now one more concept here that we need to cover, and that is working with exponents and exponents that are rational, meaning that they're ratios. And notice these are just two ways to write the exact same thing. So we're used to seeing this like the square root of 2 or the cube root of 5. But kind of a new way of writing that is instead of saying the square root, because remember the index right there is a 2, right? My exponent on this is a 1, my exponent on this is a 1. Instead of writing it like this, we can write it like this. So 2 to the 1/2 means the same thing as taking the square root of 2. So the denominator is the root, how many roots you're taking. So the cube root of 5 is 5 to the 1/3. If you have x squared, the cube root of x squared, that gives you, notice that 3 in the denominator, kind of like here, and that 2 from the exponent here would be there. And these two are actually the exact same thing, the cube root of x squared. You get the same thing. So the exponent goes up here, and the root, or the index, goes in the denominator. So let's just see if we can simplify some of these down using these rational exponents. So this first one is 64 to the negative 1/2. Well, we know that would be the same thing as 1 over 64 to the 1/2. Or we could say that's 1 over the square root of 64. And the square root of 64 is 8. So this whole thing simplifies down to that, 1 over 8. Alright, now the same idea here, kind of, is we want to take, we can kind of write this in two different ways. We can say 64, square that, and then take the cube root of that. Well, 64 times 64 is really big, so the way we could write that is like this. We could say take the cube root of 64 and then square it. Well, what times what gives you 64? Well, the cube root of 64 comes out to be, it's going to be 4. So it'll be 4 squared, because 4 times 4 gives you 64. And then 4 squared, well, 4 times 4 is 16. So this thing turns into that thing. Alright. Now, notice the base of this one is the 125. So we can kind of just, if you want to think about ignoring the negative for a second, because remember this is not the same thing as if it had said negative 125 to the negative 2/3. Right, those two are not equal. Okay, so let's do, I'm just going to leave that negative sign out there in front and see what we can do here. So let's think about it as negative 1 over 125 over 2/3. It's going to be negative 1 over the cube root of 125 squared. Again, we could have written it kind of like we did here with the squared on the inside, but then I'm going to be thinking about trying to do 125 times 125, so it's going to get really big. So instead I'm going to do this, because the cube root of 125 is just 5. So this thing's going to come out to be negative 1 over 5 squared, and 5 squared is 25, so it's going to be negative 1 over 25. So this whole thing turned into that. Alright, your homework is on page 160. You can do numbers 8 through 20 all, plus one more of your choice. Good luck.